Hello students, my name is Manoj Kumar and I am uploading my next video, and in this video we will continue same topic. The name of the topic is conversion of the complex number in polar form. Now I am going to start example number 8. Now students, see the next example, example number 8. This example is very important, example number 8. So what they have given, again they told us convert the given complex number into polar form. You can see once again they have given this complex number which is equals to minus 16 upon 1 plus iota under root 3. Now your complex number in denominator. So what you will do in the very first step, you will remove its iota from the denominator. So how we can do? Earlier I have told, we have discussed. So for this, what you will do, you will multiply and divide by denominator, but you have to change its signs and then simplify it of the brackets both parts. After getting this complex number in the form of a plus iota b, you will compare this form with general form of the polar form, and we know that is equals to z is equals to r cos theta plus iota sin theta, and then you can compare real parts to real parts and imaginary parts to imaginary parts, and after comparing them, here you will get your real parts is equals to minus 4 is equals to r cos theta, and imaginary part is here is equals to 4 under root 3 equals to r sin theta. And then let us suppose this is your first equation and it will your second equation. And what you will do? You will do the squaring of both 1 and 2 and then adding. And after adding, what you will get here, which is equals to 16 plus 48 is equals to r square into cos square theta is equals to sin square theta. And from here you will get the value of r, which is equals to 8. After getting the value of r, you will substitute this value in equation number 1 and equation number 2. And from here we will get the value of theta is cos theta is equals to minus 1 by 2 and sin theta is equals to under root 3 by 2. Now it is very important part. Now your value of cos theta is negative and value of sin theta is positive, and we know that when cos theta is negative and sin theta is positive, so it lies in a second quadrant. Where it lies in a second quadrant. So when after confirmed it lies in second quadrant, you will take this value sin theta is equals to under root 3 by 2. And from here you will find the value of theta, and value of theta that is equals to 60 or pi by 3. And again we will use that table. I have told we will use that table when our argument is lie in second quadrant. So what is the value? Pi minus alpha. Once again, that is pi minus alpha. So from here you will get the value of argument of the z is equals to pi minus pi by 3, and after simplification you will get here the argument of this complex number is here 2 pi by 3. After getting the both value of r and the argument of z, and argument of z is here this one, and the value of r is here, and this is our required polar form after substituting the value of r and z. Student, this table is very important. In first quadrant, your argument of z is here, theta is equals to alpha, and the argument of the z, that is equals to pi minus alpha, and in third quadrant, argument of z is equals to minus bracket pi minus theta, and in fourth quadrant, argument of z, that is equals to minus alpha. Now student, I am going to start exercise 5.2. So what we will do in this question, here we will find the modulus and the arguments of each of the complex number. So what is your first question? So z is equals to minus 1 minus iota under root 3. Now see its solution. Now student, you can see the solution of the very first question. So here the given complex number is z is equals to minus 1 minus iota under root 3. So what you will do in very first step? You will compare this given complex number with polar form of a complex number. So after comparing, you will get here r cos theta is equals to minus 1, and the value of its imaginary part is minus under root 3 is equals to r sin theta, and name it equation 1 and 2. And then you will do the scaling of equation number 1 and 2, and after that, after the scaling, you can add them, and after adding we get here minus 1 whole square plus under root 3 whole square is equals to r square into cos square theta plus sin square theta, and after simplification we get here 4 is equals to r square, and the value of r you can see which is equals to 2. So this is the modulus of this complex number. Now after getting the value of r, you will substitute this value in equation number 1 and equation number 2. So after substituting the value of r, here you will get cos theta is equals to minus 1 upon 2 and sin theta is equals to minus under root 3 by 2. And you can see your cos theta and sin theta, both trigonometry functions, are negative. So it means they lie in third quadrant. Please note down. When sin theta and cos theta lies in both are negative, so they lie in second quadrant. And remember, when cos theta is your negative and sin theta is positive, it lies in second quadrant, and when both are positive, they lie in first quadrant. And sin theta is positive, sin theta is negative and cos theta is positive, so they lie in fourth quadrant. So here you can see, so both are negative, so they lie in third quadrant. And then if they lie in third quadrant, so you can see this table. So what is your argument of the z? That is equals to minus bracket pi minus alpha. So here you will get the value of the alpha from these two. The question is here, how we get the value of the alpha. So for finding the value of the alpha, what you will do, students, you will take this cos theta, this one, and cos theta is equals to minus 1 by 2, but you will ignore the value of this minus. So your value of cos theta, suppose 1 by 2, and the value of the theta is here pi by 3. So this is your value of the alpha. This is your value of the alpha. Is it clear, students? So what you will do after getting the value of alpha, you will put this value here. Theta is equals to minus pi minus alpha. In place of this alpha, you will substitute the value of alpha, that is pi by 3, and after simplification you will get the value of the theta is here minus 2 pi by 3. So I hope you understand this question. Now student, we will start our new topic, and the name of the topic is quadratic equations. So in 10th class we have learned what is the quadratic equation and the solution of a quadratic equations. And there are three methods to find the solution of a quadratic equation. First is factorization, second is quadratic formula, third is completing the square. And we have learned also what are the nature of the roots. So when our discriminant, that is equals to d is equals to b square minus 4ac is greater than 0, then quadratic equation has real and distinct root. And when the value of the d is equals to b square minus 4ac is equals to 0, then it has real and equal roots. But third case, that is very important, that was the value of d is less than 0. So then we will say the quadratic equation has no real roots. But here in plus 1 we will solve this case when we don't have real roots. Now you can see clearly they have written here, suppose we have a quadratic equation ax square plus bx plus c equals to 0 with real coefficient a, b, c, and a is not equals to 0. And also let us assume that b square minus 4ac is less than 0. So we know that we can find the square root of the negative real number in the set of the complex numbers. So therefore the solution of above equations are available in the set of the complex number, which are given by x is equals to minus b plus minus under root b square minus 4ac upon 2a is equals to minus b plus minus under root 4ac minus b square iota upon 2a. Now you can see the example number 9. In example number 9, they have given a one equation x square plus 2 equals to 9, x square plus 2 equals to 0. So what is the value of here x square, which is equals to minus 2. But in earlier class we say this quadratic equation has, you can see the value of x is equals to plus minus under root minus 2. When we have any number whose square root is negative, we will say it has no real roots. But here we will use this concept and complex number. We know that minus under root 1 is equals to iota. So here you can write down in place of minus 2 iota. So which is our required result? See one more example, example number 10. Solve x square plus x plus 1 equals to 0. You can see in first step here you will find the value of d, which is equals to b square minus 4ac, and here the value of a is 1, b is 1, and c is also 1. So put the values of a, b, c here, and you will get the value of b square minus 4ac equals to minus 3. So which is negative. In 10th class, if we will get here the value of b square minus 4ac is less than 0, so we told that time कि it has no real roots. So now if we get here the value of b square minus 4ac is less than 0, so we can solve it. See the solution of this quadratic equation. Here minus 1 plus minus under root 3 upon 2 multiplied by 1. So in place of this minus under root 3, so you will use this identity. You will use this result. Under root minus 1 is equals to iota. So here you will write down iota, which is our required result. In same way we can solve the rest of the question of exercise 5.3. So for your clarification, now I am going to solve the next example, example number 11. So what they have given? They have given one equation which is equals to under root 5 x square plus x plus under root 5 equals to 0. So in first step you will find this discriminant, and we know that the formula to find the discriminant is equals to b square minus 4ac. So here you will get your discriminant is here minus 90, and its solution which is equals to x is equals to minus b plus minus under root d upon 2a. So put the values of a, b and c and then d, and you can see your discriminant is here negative, and in place of this minus 19 you will substitute here iota. So which is our required solutions of this quadratic equation. With this topic we have completed our chapter 5th. So once again, now I am going to discuss what we have done in these chapters. See the summary of this chapter. So first point, the definition of the definition of the complex number. A number of the form of a plus iota b, where a and b both are real, is called complex number, and a is called the real part and b is called the imaginary part of a complex number. And see the second point. In second point, so suppose you have two complex numbers z1 and z2, so their sum is equals to this one. You will add your real part to real part and imaginary part to imaginary part. And see second, the product of two complex number is equals to this one. And this third point is very, very important. What is that? When you will find the inverse of a given complex number. Suppose z is your given complex number. So this is your multiplicative inverse of a complex number. So please note down, it is very, very important. See the next point, the powers of iota. And the next one is, what is the conjugate of the complex number? So this is your given complex number and its conjugate is this one. Now next, polar form of a complex number. So this is very, very important. Suppose this is your given complex number and it is the polar form of the complex number, where r is the modulus of the z and theta is the argument of z. And remember, it lies between, theta is lie between minus pi to pi equals to pi. So this value is known as principal argument of z. See the last topic, the solutions of a quadratic equation when the value of the discriminant is less than 0. This is the solution. And with this, our fifth chapter is complete, and students, you will do written practice in your notebooks of this chapter again and again, and please do all the questions of miscellaneous in your fair notebook. Thanks.